This mini lathe was never designed to run G-code, but today I'm going to use it to machine complex RC turbine parts. The problem is that these nozzle components contain complex curves that are extremely difficult to produce manually. Recently, I upgraded my lathe with a nanoELS electronic lead screw system, an open source project developed by Maxim Kaczorowski. One of its most interesting features is the ability to execute G-code. So in this video, I'm going to test how far this feature can really go, what limitations I found, and whether it actually makes sense for a hobby workshop. Hi guys, I'm Alfonso, and welcome to the channel. Today we're continuing the RC Turbine project by machining the front nozzle assembly using G-code on a mini lathe. To integrate the new nanoELS system, I first needed to redesign and 3D, print a new enclosure, and also modify part of the machine wiring. Since nanoELS is fully open source, both the hardware and firmware can be customized and improved by the community. I'm using the latest firmware version available at the moment. I also modified part of the software to improve the X-axis handwheel response, which felt a bit rough in the previous version. After some testing, the machine already feels much smoother and more responsive. The front nozzle assembly is composed of two different parts, the inner ring and the outer nozzle. I'll start with the inner ring. To generate the machining paths, I'm using Fusion 360 CAM. However, nanoELS is not a full CNC controller. It only supports a reduced set of G-code instructions. Because of that, I had to modify the Fusion 360 postprocessor to replace arc commands with linear interpolation moves. I changed G0 by G1 in order to control movement speed, and I also removed unsupported instructions and simplified the output G-code as much as possible. Even after post-processing, I still needed to clean the code manually before sending it to the machine. First, I prepared the raw material with the external diameter and the center hole already machined. Then I started machining the internal profile. The result was surprisingly good considering this is still fundamentally a manual lathe. Now it's time to machine the second side. This operation could also be done manually, but I wanted to continue testing the G-code workflow. Now it's time to machine the outer nozzle. This part is considerably more difficult and requires three separate operations: front profile, rear profile, and the external side contour. During the first operation, I discovered an important problem. While manually cleaning the G-code, I accidentally removed an instruction the controller actually needed. Instead of stopping with an error, the machine simply skipped the unsupported operation and continued machining the next one. This is potentially dangerous because it can generate completely incorrect profiles without immediately noticing the problem. After fixing the code, I continued machining the lateral profile using a grooving strategy followed by a final profiling pass. However, the selected tool was not rigid enough for this operation. Because of tool deflection and cutting forces, the final surface finish was not good enough. So at this point, I decided to start over, using everything learned from the first attempt. For the second try, I changed both the machining strategy and the cutting tool. This time I used a much more rigid setup for the lateral profiling operation. And finally, the result was much better. The profile accuracy and surface finish were now exactly what I was looking for. In the end, I successfully machined both nozzle components with the required accuracy. My first experience with nanoELS has honestly been very positive. The ability to execute G-code on a small manual lathe is a huge improvement and opens many new possibilities for complex parts like these. That said, it's important to understand that nanoELS is not a true CNC controller. It behaves more like a basic G-code interpreter, so the machine still requires close supervision during operation. But for a hobby workshop, I think this system offers an excellent balance between simplicity, flexibility, and capability. And since both the hardware and software are open source, being able to modify and improve the system yourself is an extra bonus. I hope you enjoyed this episode of the RC Turbine project. If you did, consider subscribing so you don't miss the next chapter, where I'll start working on the combustion chamber. Thanks for watching, and see you in the next one.